Imagine a mirror so vast it reflects not your face but the face of time itself. This is the James Webb Space Telescope, our golden eye in the sky, built to peer into the universe's distant past. It sees light that's traveled over 13 billion years, a message from the universe's infancy. We're not looking at the universe as it is, but as it was when it was just a baby. We expected to find faint, primitive galaxies, small, disorganized, just beginning to form. It was a simple story, slow, gradual growth over billions of years. But the universe had other plans. When Webb's first images arrived, they shocked us. Instead of cosmic infants, we saw galaxies that were bright, massive, and complex, far too mature for their age. It was like finding a baby picture of a friend, only to see a fully grown adult. The universe didn't whisper its secrets, it shouted them. These galaxies challenged everything we thought we knew about cosmic evolution. Science is humbling. You build a machine to confirm what you know, and it shows you how much you have yet to learn. Webb didn't just open a new window, it shattered the old one. It forced us to question our most basic assumptions about our origins. The cosmos is more mysterious and magnificent than we ever imagined. The journey into the unknown had just begun, and already, it was rewriting the first chapter of the cosmic story. Before Webb, our picture of the early universe was clear and orderly. The Big Bang, then hundreds of millions of years of darkness, no stars, no galaxies, just a fog of hydrogen. We thought this cosmic dark age lasted a long time, a slow start to the universe's story. Our models predicted the first stars would appear after about 400 million years. These stars would group into small, clumpy protogalaxies, simple building blocks, not the grand spirals we see today. Galaxy formation was supposed to be a marathon, not a sprint. Billions of years would pass before majestic galaxies and heavy elements emerged. Supermassive black holes? They'd be tiny seeds waiting to grow. We expected to find a universe poor in heavy elements, with only hydrogen and helium. Our standard model was built on decades of observation and theory. It was a good story, logical, supported by evidence. So when we aimed Webb at the dawn of time, we had a checklist: small, faint galaxies, few heavy elements, tiny black holes. But the universe had written a very different script. The first images from Webb would upend everything. Our expectations were about to be shattered. The universe, it turned out, was in a hurry, and we were about to find out just how much we didn't know. Webb's first deep field images stunned the scientific community. Where we expected cosmic toddlers, we found galaxies that looked fully grown, massive, bright, and structured, just 500–700 million years after the Big Bang. Spiral galaxies, complex systems we thought took billions of years to form, were already there. It was like finding a skyscraper in an ancient village. Even more surprising, Webb detected heavy elements, carbon, oxygen, neon, in these early galaxies. That means several generations of stars had already lived and died, enriching the cosmos far faster than we thought possible. And then, the biggest shock, a supermassive black hole billions of times the mass of our sun, less than 1 billion years after the Big Bang. Our models can't explain how such a monster could form so quickly. The universe had a secret recipe for building complexity, and it started cooking right away. Our neat story of cosmic origins was in tatters. Webb forced us to rethink everything about how galaxies, stars, and black holes form. The early universe was far more dynamic and creative than we ever imagined. The cosmic script had been rewritten. Imagine you're a historian. You expect to find baby photos from a lost civilization, but instead, you find teenagers walking, talking, writing poetry, just a year after the first births. That's the shock astronomers felt with Webb's discoveries. We expected cosmic infants, but found galaxies already acting like adolescents, massive, complex, and active. These galaxies had already built up huge populations of stars and intricate structures. They were merging, forming stars, and evolving at a pace we thought impossible. This isn't a minor tweak to our theories, it's a fundamental challenge. Maybe the early universe was more efficient at building complexity. Perhaps the first stars were bigger, faster, and more productive than we thought. Or maybe unknown processes allowed galaxies to assemble at breakneck speed. It's as if the universe had a quick start guide we never knew existed. We're now the historians, staring at impossible photographs. Our models need a complete overhaul. The universe's early years were far more eventful than we ever dreamed, and we're only beginning to understand how. Webb's secret weapon is spectroscopy, breaking light into its colors to reveal the chemical makeup of distant galaxies. Before Webb, we thought the first galaxies would be chemically primitive, mostly hydrogen and helium. Heavy elements like carbon and oxygen were supposed to take billions of years to appear. But Webb found their signatures in galaxies less than 1 billion years old. That means several generations of massive stars had already lived, died, and seeded the cosmos with heavy elements. The universe's factories were working overtime from the very beginning. This changes everything. Heavy elements are essential for rocky planets and life. Finding them so early means the universe became hospitable to complexity much sooner than we thought. The stage for planets, and maybe life, was set almost immediately. The universe didn't wait to get interesting. As we sifted through Webb's data, we noticed something unexpected: patterns in the arrangement of galaxies. The universe we thought should be random on the largest scales. But Webb revealed a surprising amount of order, especially the golden spiral, a pattern found in nature on Earth. To see it echoed in the earliest galaxies is uncanny. Is this a fluke or a clue to a deeper rule? Maybe the laws that shape galaxies and life are more unified than we imagined. Perhaps the universe prefers certain geometric forms, a hidden architecture guiding complexity. These patterns suggest the cosmos isn't just chaos and chance. There may be elegant mathematical principles at work, shaping everything from seashells to galaxies. The universe might be less random and more beautiful than we ever thought. Webb is revealing a hidden order in the cosmos. One Webb discovery stands out: 6 massive galaxies 11 billion years ago, orbiting a central black hole, not randomly but in a perfect hexagon. It's been nicknamed the Flower. Such geometric precision seems impossible by chance. Our simulations produce messy clusters, not perfect shapes. What could create such order? Maybe vast filaments of dark matter or a new force of nature. This challenges our belief that the universe is the same in all directions. The Flower hints at preferred arrangements in the fabric of space itself. It blurs the line between physics and philosophy. Is the universe just random, or is there a deeper hidden order? The Flower asks a question we can't yet answer. These discoveries push us to the edge of what we know. They force us to ask, does observing the universe change what we see? In quantum mechanics, the observer affects the outcome. Could something similar happen on the cosmic scale? Webb was built to find a baby universe, but instead we found one already grown, filled with patterns that echo life on Earth. It's as if the universe knew we were looking and decided to surprise us. Maybe consciousness isn't just a cosmic accident. Perhaps the universe is structured to be known, and in being known, becomes complete. We're not just passive observers, we're part of the story. Webb has given us new questions, deeper and more mysterious than before. The cosmos is wilder and more creative than we imagined. We're explorers on a new continent with a useless map. All we can do is stand in awe, keep looking, and embrace the magnificent uncertainty of it all.